try some question. Okay, so for example 1, macam biasakan diri untuk lukis. Okay, biasakan diri untuk lukis. So example 1, Roman 1. Okay, so it says that 100 Newton force is applied to move a 15 kg object a horizontal distance of 5 meter. Okay, maksudnya, okay, ini objek kita. Contoh Miss lukis, this is our object, and 100 Newton force is applied. Okay, 100 Newton force is applied to move the object. Okay, to move the object for a distance of 5 meter. Okay, to move the object for a distance of 5 meter. So kita ingat balik equation untuk work done kita. Work done equals to Fs cos theta. Okay, so our force is 100 Newton. Our displacement is 5 meter. Okay, then you check your theta, angle between F and S. Theta F force kita ke kanan, displacement kita pun ke kanan juga. So angle between them is 0 degree. So kita dapat work done kita, okay, work done kita equals to 500, and the unit of work done is joules. Okay, so that is adalah untuk example 1 Roman 1. Okay, kita move on to the next one. Example 1 Roman 2. 100 Newton force is applied at an angle 30 degree to the horizontal. Okay, to move a 15 kg object for a horizontal distance of 5 meter. Again, kita lukis dulu. So this is our object, and the force is applied with an angle of 30 degree to the horizontal. So ni horizontal kita, angle kita kat sini is 30 degree. So this is our force. Okay, displacement kita adalah S kita lah kat bawah ni. So displacement kita adalah sebanyak 5 meter. Okay, again, write down your equation. Work done equals to Fs cos theta. Okay, the force applied, force dia masih sama, 100 Newton. So 100 darab dengan displacement kita which is 5 meter. Cos theta is the angle between the displacement and the force. Sekarang displacement kita dekat sini, horizontal displacement. Force kita ke atas, angle dia adalah 30 degree. So ibarat displacement kita kat sini, force kita ke atas. So angle between the force and the displacement is 30 degree. So kita substitute sahaja 30 degree dan kita akan dapat work done. Okay, work done is 433.02 joules. Okay, 433.02 joules. Okay, kita move on to the third question. Okay, lukis dulu. Make sure you always draw first. Soalan yang ketiga. Okay, soalan yang ketiga. An upward force is applied to lift a 15 kg object to a height of 5 meter. So this is our object. Okay, force kita ke atas. Okay, force kita dikata upward force. So, maksudnya force kita ke atas. Okay, to lift the 15 kg object for a height of 5 meter. 15 kg object for a height of 5 meter. Okay, so force kita. Okay, so kita akan cari balik work done. Work done equals to Fs cos theta. Okay, so force kita adalah 100 and displacement kita masih 5 meter. Okay, and angle between the force and the displacement is 0. Okay, cos 0. So again kita akan dapat 500 joules. Okay, so that is example number 1. Okay, moving on to example number 2. Okay, moving on to example number 2. Kita akan tengok, we have to, you push your physics reference book 1.5 meter along a horizontal table. Okay, kita push a physics books 1.5 meter along a horizontal table. Okay, with a force of 5 Newton. Okay, the frictional force is 1.60 Newton. Calculate the work done by the 5.0 Newton force. So, kita ada beberapa work done dekat sini, ada 2 force. So kita cari satu-satu dulu. Okay, work done by the external force. Okay, work done by the external force equals to, kita tulis balik equation Fs cos theta. Okay, force kita adalah 5. Sekarang kita nak consider untuk force 5 Newton. Okay, displacement is already given 1.5 meter. So 1.5 cos theta. Okay, you imagine this is your reference book. Okay, this is your reference book. Okay, and a force is applied. Okay, force kita ke sini. Force dia adalah 5 Newton. Okay, and displacement dia adalah 1.5 meter. Okay, so the angle between the force and the displacement, both of it is to the right. So angle dia adalah 0 degree. So kita akan dapat work done by the external force equals to 7.5 joules. Okay, 7.5 joules. So that is for the first one. Untuk yang kedua, okay, dia nak work done by the frictional force. So we know kalau force kita ke depan, frictional force kita akan ke belakang. The frictional force akan resist the motion of the book. So frictional force kita akan ke belakang. So again, kita tulis dulu work done by frictional force. Kalau tadi adalah external force, this one is work done by frictional force equals to Fs cos theta. Okay, so kita gantikan force. So force ni adalah frictional force dah lah. Okay, sebab sekarang force ni, I told you tadi, capital F ni boleh represent any one of the force. So for this one, kalau kita nak cari work done untuk frictional force, F kita kat sini adalah frictional force. So frictional force kita is 1.6. Okay, 1.6 darab dengan displacement kita, sama juga displacement kita is 1.5 meter. And your theta, kita tengok displacement you ke kanan, friction you ke kiri. So angle between force and displacement is 180 degree. Okay, tengok balik, if Miss lukis balik, displacement ke kanan, frictional force you ke kiri. So angle between your frictional force and your displacement is 180 degree. Dia lain kalau tadi external force awak ke kanan, displacement awak pun ke kanan juga. So yang ni theta you adalah 0 lah. Kalau this one, your theta is 180 degree. So kita akan tekan, so kita akan masukkan sebagai cos. Okay, cos 180 degree. Okay, so when you press your calculator, you akan dapat negative 2.4 joules. Okay, so now that we've already have our work done by our external force and work done by our friction, so total work done, okay, nombor 3 is total work done. So we know total work done kita akan tambah lah, equals to work done by our external force tambah dengan work done of our frictional force. So kita tambahkan dia sahaja. So 7.5 kita akan tambah dengan negative 2.4. So kita akan dapat final answer kita 5.1 joules. Okay, so make sure you check your angle. Sekarang frictional force dengan displacement is 180. Okay, so bila kita masukkan angle kita 180, so kita akan dapat work done by friction. Okay, so this one is external force. Okay, and this one is frictional force. Okay, so that is example 2. Okay, kita teruskan ke example 3. Okay, so for example 3, okay, for example 3, you are given a graph F against S. Okay, so the question says a horizontal force is applied to a 2 kg radio control car. Okay, the force varies with displacement. So they want us to calculate the work done by the force F when the car moves from 0 to 7 meter. So ingat balik, if you're given graph F against S dan kita nak cari work done, it's actually kita kena cari area under the graph dia. Okay, kita nak cari area under the graph. So you have a few option macam mana you nak buat dia. Okay, for me, Miss akan pecahkan dia kepada 3 part. So this one is a trapezium. Okay, ada banyak cara, it's up to you. So this one Miss letakkan sebagai A, trapezium. This one triangle B, and this one is another triangle C. Okay, so make sure you write dulu work. Okay, work equals to area under the graph. Okay, work equals to area under the graph. So area dia ada 3 lah. So kita cari untuk A dulu. So A is a trapezium, so 1/2. So we add up the length. So the first one is 5. Okay, tambah dengan 2. Okay, kat sini length dia adalah 5. Kat atas ni 2. Okay, darab dengan the height of the trapezium, which is 5. Okay, so darab dengan 5. Dan kita akan tambahkan dengan area of the triangle B. So this one is going to be 1/2 darab dengan the length, which is 1, darab dengan the height, which is 5. Okay, tambah dengan area untuk yang C. So 1/2 darab dengan length dia, okay, which is 1 juga, and darab dengan height dia, which is -4. So kita akan dapat the work done equals to 18 joules. Okay, so that's for example 3. So kita cari sahaja. You have to remember work equals to area under the graph. And wajib tulis yang ini sebab kat sini ada markah. Okay, so work equals to area under the graph. So that is example 3, quite straightforward. Okay, next we continue with example 4. Okay, so for example 4, the question says that how much work is done against gravity. So they want how much work is done against gravity in lifting a 3 kg object through a vertical distance of 40 cm. Okay, so for this one, okay, kita lukis free body diagram dulu. So we have the weight which is downwards. Okay, and now we want to apply a force, okay, to work against gravity. Okay, so the force is going to be upwards. Okay, and the displacement is also upwards. Okay, so here the main concept here is to lift the object. Okay, to lift the object, we have to apply a force equal or more than the weight. Okay, so when we apply an external force equal or more than the weight, barulah objek tu we can lift the object. Okay, so untuk kita mengangkat objek itu, okay, so kita kena apply force yang sama dengan weight ataupun lebih besar daripada weight. So that's what it means. So they want to find out how much work is done against gravity. Okay, so kita dah lukis, and then we write down our equation, which is W equals to Fs cos theta. Okay, W equals to Fs cos theta, and our force here, okay, like I said, our force here needs to be equal or more than our weight. So we can replace our force here with mg. Okay, how much force needs to be applied has to be equal or more than the weight. Then we can lift the object. Okay, multiply by the displacement and cos theta. So we can insert the value. So mass of the box is 3 kg, g is 9.81, and the displacement, okay, the displacement is 40 cm. So make sure you convert it to meter. So 40 times 10 to the power of -2 cos theta. So the force, the angle between the force and the displacement is 0 degree. Again, don't take the angle between the weight and the displacement, no, because now the force applied is this force. Okay, but kita nak cari how much force should we apply here to work against gravity. So the force applied should be equal to the weight, then we can lift the object. Okay, so when you press your calculator, kita akan dapat 11.77 joules. Okay, so then kita boleh buat ayat to, okay, to lift the object. Okay, to lift the object, we need to apply, to lift the object, we need to apply a force equal to, okay, a force equal to the mg, to the weight lah, okay, to the weight, to overcome the downward gravity. So for us to overcome the downward gravity, we need to apply a force equals to the weight. Okay, for us to overcome the downward gravity, we need to apply a force equal to the weight. Okay, so kita perlukan force yang sama dengan mg. Okay, sebab itu work done against gravity. Okay, so this is for example 4. And we move on to the last example for this subtopic, which is example 5. Okay, example 5, you're given a graph f against x. Okay, f against x. So it's actually the same. So x is actually the distance. So it's the same with f against displacement. So you're given a distance here. Okay, so a force F acting on a particle varies with displacement x, as shown in figure below. Calculate the work done. Okay, calculate the work done by the force as the particle moved from x equals to 0 to x equals to 6 meter. So remember when we have a force against displacement graph, for us to calculate the work, we can calculate the area under the graph. Okay, so make sure we write that down. So work done equals to area under the graph. Okay, area under the graph. So our area under the graph is a trapezium. Okay, so we can take 1 over 2, 6 plus 4, multiply by the height, which is 5. Okay, so we can get our work done to be 25 joules. So this is the final answer. Very straightforward. So remember, if you're given a graph, F against displacement, F against distance, so we can actually find the area under the graph, okay, to calculate the work done. Okay, so that's all for 5.1 work. So that's for example 1 until example 5. Thank you.